Everybody. We're on to Unit 5, Presentation 3. So leading up to this, right, we talked about number one, the properties of matter, right, how we can describe matter. And then we talked about how matter can be a mixture of things, right? And then this week, what we're going to be talking about is that matter can be different states. Depending on temperature and energy, we can have solids, we can have liquids, and we can have gases, right? Those are the three that we're going to be talking about, at least states of matter wise. So here we go.
All right, here we go. All right, so basically matter is anything that takes up space, right? So anything that has mass and volume. We talked about mass and volume in Unit 3 when we talked about density and buoyancy and that kind of stuff. But now we're going to start talking about matter in the sense of chemicals and how is these molecules and these particles move. That's what this week is about. I'm not sure how much of this kind of stuff that you guys have talked about in the past, but I'm sure most of you guys have learned the states of matter. In this case, solid, liquid, and gas. There's a fourth one, plasma. We're not really going to talk too much about it because you don't find it here on Earth all that much, but it is actually, plasma is the number one most found states of matter in our entire universe, and that's because all stars are made up of plasma. But here on Earth, we really don't see that. So that's the reason why we're going to stick to just solid, liquid, and gases. I'm not really going to let know about anything like that. All right, but the idea is this, and this is a kind of an important part. How the molecules move determines the state of matter. Right? And we'll talk about temperature and how that relates to it too. But temperature is basically just the measure of how fast an object or how fast molecules move. I know we talk about temperature in the sense of like how hot or how cold something is, but really all it is how fast are the molecules inside of that matter moving. All right, so we're going to go over each state and how they move and what they comprise of, and we'll move from there. So the first state, which is solids, these are the ones that are the lowest in energy out of all the ones that we're going to talk about. And the reason why is because these molecules that are inside of matter, and I'm not sure how much of molecules that you guys have learned, but molecules are these little tiny things that make up matter. All right, we'll talk about atoms and all that stuff a little bit later to be a little bit more specific, but basically because of gravity, these molecules are little tiny little balls. All right, and because they move so little in solids, we can say that they have a very low in energy. All right, they don't have a lot of energy in them. They do have a definite volume. What that means is you can't change the volume of something. So in other words, you can't make a solid bigger or smaller unless you add stuff to it, which you can't. So like in other words, if I had a hamburger, it's not like I can increase the volume of the hamburger to make it bigger, right? The only way I could do that is by adding more burgers to it or adding more buns to it. But other than that, it keeps its definite volume. It also keeps its definite shape, meaning that I can't just change the shape of it unless obviously I grab it and I rip it apart. But on its own, it can't change shape. So if I go back to the hamburger idea, the hamburger can't all of a sudden change to become an orange, right? It's gonna keep its shape, right? It's gonna keep its round shape as it is. It does not change, right? So that's solids, and there's a little picture of a solid moving. And as we go through this, when you see a little picture like this, I want you to draw it. Obviously, you're not going to be able to draw the moving parts, but I want you to be able to draw the little particles. It's going to help you visualize these, because part of chemistry that's very, very difficult is that you don't see these little particles, right? We haven't created a microscope or anything like that that can see that small. It's really, really tiny, but there's a lot of evidence to prove that this is what it looks like if we were to have seen with a microscope. Okay, so the second state of matter, or I'm sorry, there's two types of solids if I want to go into it. There's what's called crystalline and there's amorphous. All right, and basically crystalline is just like what the picture shows. It's a repeating pattern of arrangements of these molecules. All right, so what that makes it is it makes it very, very a lot more manageable, a lot more predictable for a lot of things. Amorphous is just very, very random. It's very, very messy the way the molecules are put together, which makes it less predictable to know its behavior and how it's going to function in the world. A diamond is a good example of a crystalline. If you've ever seen a diamond, you've seen these patterns are really, really cool. Amorphous is just a really quick one is plastic. Glass is also another type of amorphous solid, and so on. But they're just very, very random. All right. All right. So let's go to liquids now. Okay. Liquids have the second. Their lowest energy level. They're still pretty low, and the reason why I say the energy level is pretty low is because, as you can see from the pictures, they don't move all that much either. All they do is these molecules can just slide past one another, right? That's it. That's all they can do. And if you look at it, the picture, it looks very similar to a solid, except for the fact that they're just kind of a little bit, have a little bit more space apart from one another, right? But it's a little bit more movement. And that's the reason why, because it moves a little bit more, it's got a little bit more energy than the solids do. All right. Again, just like solids, liquids have a definite volume, meaning that I can't increase or decrease a given amount. So in other words, if I had a can of Coke, all right, it's not like I have a never-ending supply. I can't just make more Coke out of nothing. If I'm given a can of Coke, that's all I get. If I drink it all, it's gone. All right, so I can't increase or decrease the volume. However, the difference between that and solids, or liquids and solids, is that it does not have a definite shape, meaning that liquids can change its shape no problem. In other words, it can take the shape of a container. So the way liquids change its shape, put it in a different container. For example, if I had a can that was a box, my liquid's going to look like a box. If I then take my liquid and pour it into a cylinder, it's going to take the shape of a cylinder. All right? It's not going to increase its volume. It's always going to be the same amount. However, it can change its shape based on what container it's in. All right? So again, make sure you draw this. I know it's going to look a little bit more like an amorphous solid, and it might, but just know that the liquids, what they can do is each molecule can kind of slide past one another, so it can move from one end to the other. That's the reason why when you jiggle like a glass of water, it sloshes. And it sloshes because of the fact that the molecules can move past one another. They can go slide side by side, unlike solids. If I had like an ice cube in my like cup, if I slosh it, it's gonna just go clank, 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 clank. You're not gonna see any change in shape, but a liquid you can. All right, finally, our last one that we're going to talk about, gas. Okay, now these gases, they move very, very fast, and they move independently, meaning that it doesn't rely on other molecules like solids and liquids do. These are super high in energy, and that's because they move around like this. If you look at the picture right here, this animation, they move around really, really quick, which means that they're going to have a lot more energy, a lot more punch than a solid is going to have. And hopefully, like when you watch some of the videos that you're going to watch later on, this kind of high energy or low energy in the solids case is going to help you understand why some of the things that you're going to watch in these videos occur. Okay, now for gases, right, they don't have a definite volume, right? In other words, gases can increase or decrease how big they are. And the way they can do that is by what container that you put them in. If you put them in a really, really small, like if you take just a gas, you put it in a room, it's going to take up the entire space of the entire room. All right. While if I took that same amount, I can take it and I can compress it into a small little container. So depending on the size of the container depends on how big of a volume I'm going to have. All right. Same thing with shape. It is going to take the shape of a container. All right, just like liquids. What will happen is if I put it into a cylinder, the gas is going to take the shape of a cylinder. If I put it in a box, it's going to take the shape of a box. So it's going to take the shape of anything that I put all that gas into. All right, so there's a lot of similarities between all these, and there's some differences. But big thing that I want you to get out of this is that as you go from a solid to a gas, you're increasing the energy of these molecules, right? And when you increase these um, the energy levels, you can do a lot of cool things with that. Okay, and I'll show you some videos based on that. All right. So now, when you change, we call this changes of state or phase. You'll also hear it as phase changes. All right, let me write this. Phase changes. All right, and when objects go from a solid liquid to a gas, there's a name for that. Now, I want to make this very clear because some people don't really understand this. Every object, so every piece of matter can go through all these phase changes. Gold, all right, we always think of this as like water, for example. We know that water, we can freeze it, we can boil it, we can do all these things. You can do that with gold too. Right now, we all see gold in jewelry and stuff like that. But if I like, it's obviously a solid. But if I heat that up, I can make it into a liquid gold. And if I heat that up even further, I can make gas gold. Right now, the difference is you don't see that very often, just because we don't make gold go up 900 degrees in order to reach its boiling point. All right, we just don't do that kind of stuff because it's not worth it. It's too much energy for us to do that kind of stuff. But every object, regardless, oxygen, I could take oxygen and make it into a solid. Right now, I'd have to make it, really, really cold. I have to make it like negative, like 300 degrees in order for me to be able to do that. But I can. I could do that if I really, really wanted to. Right? So all that matters. Now, there's 6 different phase changes that can occur. Right? First one is melting. This is pretty obvious. Right? We talk about this all the time. Right? We're seeing it now as all the snow is melting into a liquid. All right, freezing. We're seeing this too. Right? I'm seeing it way more than I want to see it. Right? This is where a liquid turns into a solid. Right? Just like how water turns into ice. Right? Vaporization. And sometimes you're going to see this as evaporation. The difference between evaporation and vaporization is where you have to put energy into it to do this. So this is where a liquid turns into a gas. So in other words, where you take water and you boil it, so it turns into a gas. Okay, condensation. All right, this happens a lot in the fall or even in the spring. All right, where you'll get a lot of water in the air, and then all of a sudden when you come outside, you'll see that things are wet. You're like, did it rain last night? No. What happened was when the temperatures kind of cool down at night, all that water that was in the air turns into a liquid. So you'll start seeing your grass getting wet and all that stuff, even though it didn't rain. All right, the last two you don't see as much. First one, sublimation. All right, this is where solid turns into a gas. All right, and a big one that a lot of you guys might see is dry ice. Dry ice looks like an ice, kind of like a little cube, and when you put it into air, it turns into clouds. If you've probably worked in like maybe like in the theater or something like that, they use this to create fog. I'm not sure in the BC Applause and stuff they use this kind of, but they get fans and they get dry ice and they'll blow it out to create this like foggy kind of mist. And then the last one is deposition. You don't see this too often. This is where gas turns into a solid. The best one that I can show you is where you get frost. So like this is a picture of frost on the windows. So like, obviously right now, sometimes in the morning, you'll see that your windows are clear and then all of a sudden you wake up and you got this frost on the windows. This happens a lot on your windshields on the car if you park it outside, right? And then you have to use a scraper, right, to scrape it off. Well, a lot of times it gets so cold so quickly that the air, like the water in the air, just turns automatically into ice. Okay, so these are all the different phase changes that you're going to see. All right, now here's just a visual interpretation of what you see. I do want you to draw this. Okay, so please make sure that you take the time to draw this this diagram to show all the different ones. Now the one thing that you'll see is the part where it says evaporation right here. This is the same thing as vaporization. All right, so I'm going to write vaporization right here too. It's It's going to be kind of hard for me to do this, but vaporization. Okay, it's the same thing as evaporation. Again, evaporation is more like when where you just kind of does it on its own. For example, if you left water out, it's going to eventually evaporate. I didn't have to put energy into it. Vaporization is where you have to put energy, like boiling water and so on. But it's the same thing. You'll see it written in both the same ways. All right. All right. Last thing that we're going to talk about is a heating curve. All right. And we're going to do a lab on this so that you can see this. Again, as I stated before, every single object or matter can be turned into a solid, it can be turned into a liquid, and it can be turned into a gas. All right. And if I took a matter, any matter, all right, and if I started as a solid, right, so in other words, very, very important to know that if it started as a solid, all right, it would go up in temperature, and if I graphed it, so the temperature versus time, what you would notice is as a solid, it's going to go up in temperature, and then as it melts, you're going to notice that the temperature is going to stay exactly the same. All right, this is where what we call a phase change, right? Where B is occurring, this is what we call a phase change. Right? I'm not going to get into the specifics. If you really want to know why during a phase change you're going to see that there's no change in temperatures, I'll talk about it. All right, but at this point, you'll learn about it more when you get into chemistry in the high school. But we're not going to really go over it too much in detail. All right, and then when it turns all from a solid to a liquid, that's when you're going to see all the temperature rising again. Okay, and then when it gets to up here, this is where it goes through another phase change. All right, in this case, it's going to go through vaporization. All right, so this is where it's going to now turn from a liquid to a gas. And once everything is turned into a gas, it's then going to go back up in temperature. All right, and again, like I said again, you're going to see these plateaus. I know sometimes you might think, if I'm heating something up, shouldn't I just see one big line going straight up where it's just going to keep increasing in temperature? It's not always the case. Whenever it's changing its phase, you're going to see a plateau. You're going to see time going by without the temperature changing. Okay, again, I'm not going to go through all the details of all that stuff. All right.